Hi everyone. Hi Deepthi. How are you
Hi,
doing?
I'm good. How are you?
I'm good. So, I had an interesting dream yesterday after a long time. So, I was dreaming about my teeth falling off and I was running, holding all my teeth.
Oh.
This after a long time I got a dream. So, that seems pretty interesting.
No, I have heard about this DMC because when we were in college and the university, I used to get this kind of dreams a lot. And then I've searched on net that this is one of the most common dreams that people get. So
Oh,
it's not uncommon. It's very common dream that people get. So let's do one thing. Let's ask LLM see what it replies to this.
okay. Let's ask ChatGPT.
Hmm. Anxiety, stress, or rather, you have a lot of stress.
Wow.
I
Should we
didn't
ask
like
it again?
it. I don't think you have any stress. Okay, let's do one thing. Just ask the same question again. Let's see what does it give now.
Oh, this is strange. Like the reasons have changed within seconds. Like
Um,
the
That's
responses
what
have
is,
been changed.
yeah, this is what is inconsistencies in LLMs that we see. That's because of a lot of other factors that depends on this.
Oh,
Yeah.
so we have the same prompt, but the responses have changed. What do you think the reason behind it is?
Yeah, so there are three parameters that would influence the deterministic of this model. So the three parameters are temperature, top P, and top K. So, yeah, let me give you a demo of how does it work. Okay, let me ask you a question, Radha. I'll give you a few words and try to construct a statement out of using those words alone. Okay, so teaching, love, I.
I love teaching.
Okay. Now let me add two more words to your space. That is LLMs and about.
Okay. You want me to add LLMs and about to these combinations?
So now you
Yeah.
have five words and try to construct statements.
Okay. So I love teaching. I love LLMs. I love teaching about LLMs. A lot of combinations are possible.
Exactly. That's what the LLM is. The way like the responses of the LLM depends on the space that it has, like the number of tokens that it is available for LLM to use. So as the number of tokens available increases, the number the variations of the LLM output also changes. Right. So let me explain this with the factors that we have and also with an example. So this is the first parameter that would influence the LLM inconsistencies is temperature, right? So do you know what is logit?
Yeah, this is that output from the neural network before we pass it into the softmax layer, right?
Exactly. So the model calculates the values for each and every token that it would want to predict the next, right? So that value is called the logit. So the
Yeah.
model calculates the logit and then later on it is passed to the softmax function. So
Mhm.
the temperature interferes in this particular softmax function. If you see, our softmax function is e power z by sigma e power z. Z is nothing but a logit for each token, right? So here 1 to k are the number of tokens we have. And here the temperature is like we divide the logit by temperature and so that our probabilities change for each of the token. Let's see how does it change with the change in value of t. Okay, so this is my softmax function, and these are the various words that I have given to you. And then I have the probabilities. Let's say I have chosen the first word to be I, and then now I have four words out of which I need to choose one. What will be the
Mhm.
most probable next word, right?
Mhm.
Let's say these are the logics that was calculated by the model. And
Yeah.
now let's say, see, temperature value can be anything. Like it can be greater than 1, is equal to 1, and less than 1. Let's see what happens if we put greater than 1. I'll just run it. So these are the various probabilities that I have got, right? And now let me see when temperature is equal to 1, what will be the probabilities. And if you see here, when the temperature is greater than 1, the logit with the lowest value, the probability of the lowest logit is increasing, which
Yeah,
is
the
again,
weight is increasing for the least common also. I mean, like the importances of each word are decreasing. It's becoming generic.
that's true. So, which is not actually acceptable in the large language models, right? So, we generally don't have temperature greater than 1. So, the only temperatures that are allowed is 0 to 1. So, if the temperature is 1, it remains as it is. We are not increasing or decreasing the weightage for each of the words. But if you are reducing the temperature, that's where you see the change. So as the temperature approaches to 0, the probability of the uh, larger logit increases. So we are trying to confine it to a single word. Let's say now if it's zero point 0.7, so from 0.41 it has increased to 0.949. That is the probability of the higher logit increasing. Let me put it as zero
So,
point 0.5 now. Earlier it was 0.49, now it's 0.57. It's increasing. And
so
rest
the
all are decreasing.
okay. So the creativity of the model is decreasing.
Exactly. So if I keep it very low, that zero point 0.1, then it's 0.98. So
Mm,
it's just
yeah.
that we are trying to eliminate the other words entirely and asking it to like the probability of the highest logit keeps increasing such that the model only picks this word. It doesn't pick the other words based on the probabilities.
Okay. So, I mean, like if the temperature is very, very low, it will always give the same output. Like
Mm,
even if you give a 100-word vocabulary, it will choose
mm,
only one with the highest. We can't expect creativity in responses.
exactly. Correct.
Okay. So, what can we go to top K now? What does that talk about?
Yes. 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 Huh. So top K is nothing but we are just choosing the number of tokens that you would like to use. Let's say we have these probabilities right now. Like we already got these probabilities based on temperature. Let's have these probabilities, and now we sort them based on a descending order. We sort it on based on descending order, and then now our probabilities are these. So now let's say if you have put top K as 3, it means that we are choosing the top 3 probabilities, the number of tokens that we wanted to use.
Okay. These tokens will be considered for the response.
Exactly.
Top
Yes.
three
So,
tokens.
correct. So ideally there are 4 tokens, but now by putting a restriction on top K, we are only picking the top 3 words for constructing of the statement. Right?
Mm-hmm.
So there's one more process. What happens is like once we choose the top 3 tokens, and then the softmax function is recalculated and the probabilities are calculated again, such that the sum of these 3 probabilities is equal to 1.
Yeah.
Yeah. So later on, based on these probabilities, a word is chosen as the next word. That's the top K. So if at all you put in top K as 1, then it would choose the only one value. The first value it will choose. If you are putting it 100, then it will try to choose one among those 100 tokens or 100 words.
Okay.
That's
Okay.
how increasing top K will increase your creativity and reducing your top K will make your model more deterministic.
Deterministic. Yeah. So what is it about top P? What do we have here?
Top P is nothing but it is based on selecting the number of tokens based on the probability. So generally probability is between 0 to 1. So the top P value can go
Mhm.
between 0 to 1 only. So it is like first the same thing. First we once we get the probabilities, we sort it in a descending order. So these are your probabilities, and then if then we calculate the cumulative sum. So let's say this is the first value 0.49. The cumulative sum would be for the like when you add up the second one, the cumulative sum will be 0.49 plus 0.27. So that becomes a cumulative sum. So
Mhm.
if your cumulative sum is greater than or equal to top P, those tokens are considered for the sampling. So if you see here, let's say if I have put top P as zero point 0.6, then you are allowed to choose first two tokens. We
Yeah,
don't put
because
the second.
their sum
Mhm.
will amount to 0.6.
Exactly. So let's
Yeah,
say you have chosen zero point 0.4, then what? How many number of tokens you'll pick?
only first thing, because
Ex-
0.49 exceeds point 0.4, right?
yes, exactly. So that's how it is. Let's say if I have changed it to zero point 0.4, then you will only choose the first token.
Okay,
If you're changing it to, let's say, zero point 0.9, then you choose three tokens.
3 tokens. Okay.
That's
So
how it
if we
is.
put top P equal to 0, then it will choose only first token?
Yes.
Yes. Okay. Yeah, got it.
So once you have your tokens, let's say you have more than one tokens, like have put zero point 0.6 and then have more than one tokens. Here also, once we get these probabilities, we recalculate the softmax function and get the new probabilities of these. So this will both will sum up to one now. So now based on the probability
Oh,
distribution, we pick one value.
okay. 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 So in order to make a model deterministic, we'll have to reduce all the values. Oh, by the way, what happens if we reduce our temperature to 0?
Okay, let's check this. See, you have seen the formula, right? If you see temperature is in the denominator, the denominator can never be zero. You'll get a zero division error, right? So even though you put your temperature as zero, it doesn't mean exact zero. It just mean that it's close to zero. That's it. Like say if your value is close to zero, your most probable logic will become more or less like one, very near to one, and rest all will become zero. That's how the sampling is confined to one word when you reduce the temperature to zero. But it's not exactly zero, it's just very close to zero. But in
Oh,
LLMs, we can put the value as zero, but in the backend, they'll be putting a very number very close to zero, but not the exact zero. That we'll have to understand. But you can have the value zero in the LLMs. And when it comes to LLMs, for ChatGPT, we have two parameters, that is temperature and top P. There is no parameter top K that they have defined, but in the backend, based on top P itself, they are choosing the top K, I guess. So they have given only two parameters. But when it comes to Claude Haiku, there are three parameters available: temperature, top P, and top K. All the three you can set some values to it.
oh, okay. Okay. So, I mean, in the back end, like, what is the priority order? Like, what will it take?
Oh, okay. So let's say we have given temperature, top P, and top K. If we have defined all the three values, then what will be the order of execution, right?
Yes, yes,
So
yes.
first it will pick the temperature value. So based on the temperature, it will calculate the probabilities.
Mm-hmm.
Post that, it will check the top K value based on the probabilities, based on the new probabilities that we have got after calculating using the temperature. We pick the top K tokens
Mm-hmm.
and then recalculate your probabilities. Once you recalculate, we use top P based on the cumulative probabilities. We pick the tokens based on the top P value. And then we recalculate the probabilities. And finally, the value will be picked using this probability distribution after top.
Okay. So the order is temperature, top K, and top P, right?
Yes, yes.
We won't be able to change the order. Okay, nice. So our model will become entirely deterministic if temperature is 0, top P is 0, top K is 1. Is it or no?
Uh, yeah. So when it comes to large language, this is true, like what you have said is true, if it's a smaller LLMs, like 24 billion models, like a very smaller LLMs, it seems to be true. But when it comes to large models like ChatGPT and Claude Haiku, if you have OpenAI keys or API keys with you, if you can try this out as well. Even though you put temperature 0, top P0, and top K1, you won't be getting the deterministic responses every time. Like it will be more towards deterministic, but not 100% deterministic. Let's say 99% deterministic it could be, but not 100%. There is a strong reason behind this. I would want you to explore the reason for this because it's very interesting. So, if at all you know the answer, please comment us on the chat box. Else, we'll be revealing the response in the next lecture series, next lecture
Yeah,
video.
sure. And also, if you need any information regarding updated topics, you want us to make video about that topic, please let us know in the comments and we'll make a video on that. Thank you.
Yes, sure. We are here to teach you and learn together and grow together. Happy learning, guys. Bye.
Bye.